Hi, this is Sonia Doucette. In this video, I'll show you how to find the oxidation number for a variety of different elements so that you can determine which substance is oxidized and which is reduced in a chemical reaction, and specifically in an oxidation-reduction reaction. So the first equation here shows two magnesiums in solid form reacting with one oxygen gas molecule to give you two magnesium oxides in solid form. So you can look at the reactants first. Both magnesium solid and oxygen gas are in what's known as a free elemental form, or in their elemental form. So when that's the case, and it's usually just an element by itself, like magnesium in solid form, or it's bonded to itself in a gaseous form, such as with oxygen, but no other elements are involved. So it's kind of like they're in their pure form. So when things are in that form, the oxidation number is going to be 0. So the oxidation number for magnesium is going to be 0, and for oxygen in the reactants is going to be 0. So that's only when they're by themselves. In the product, you have a different story. So when oxygen is bonded to something, it's going to have an oxidation number almost always of -2. So the oxidation numbers for all of the elements in a given compound have to sum to the charge on that compound. In the case of magnesium oxide solid, the charge is 0. It's a neutral compound. So that means the oxidation number for magnesium plus the oxidation number for oxygen have to equal 0. So you can easily see if that has to be true, then the oxidation number for magnesium in the magnesium oxide compound is going to have to be +2, because +2 plus a -2 is going to give you a 0. So you've assigned an oxidation number to each element involved in this reaction, and now you need to look at how those oxidation numbers change from reactant to product in order to figure out which substance is oxidized and which is reduced. So magnesium, you can see, goes from 0 to +2. And oxygen goes from 0 to -2. So what's really happening here from magnesium is you're actually losing 2 electrons because you're going to a more positive charge. And for oxygen, when you go from reactant to product, you're actually gaining 2 electrons because you're going from 0 to a more negative charge. So there are 2 ways to remember what's happening with electrons when something is oxidized and something is reduced. One way is this expression: Leo, the lion, says grr. And the reason you can use this, and it seems like kind of a silly sentence, but you look at the Leo and the grr parts, which are in all caps. The L stands for lose electrons, oxidation. And the grr would be gain electrons is reduction. Another way to try to remember this is oil rig. Same kind of idea, except it's said a little bit differently. So it's oxidation is loss, reduction is gain. So I tend to use the first one. You can use either one though. So as you're looking at magnesium, you can see that electrons are lost. So electrons lose electrons, oxidation. So you can say that the magnesium solid reactant is oxidized. And then if you look at oxygen, you can see that it's gained electrons, so gain electrons reduced. So that means that your oxygen gas is reduced in this problem. So this second example is a little bit more complicated. So what you want to do here, just as in the previous example, is to figure out the oxidation number for all of the elements in all of the reactants and products. So carbon as the reactant and iron in the products are both in their free elemental form. And as mentioned before, the oxidation number in that case is always going to be 0. So those are the easy ones. Now let's look at the iron oxide reactant. So as mentioned before, oxygen is almost always going to be -2. And you can almost always write that one first, and then figure out what the other one is based on the -2 for oxygen. So notice you have subscripts here. And remember from the previous example that the oxidation numbers have to add up to the charge on the compound. In this case, you have a neutral charge as well. So it's not only the oxidation numbers, but it's the oxidation numbers multiplied by their subscripts that have to add up to 0. So in this case, you're going to have to take that subscript of 3 for oxygen and multiply the -2 by 3 to give you -6. So in order to get to 0, the iron side is going to have to be +6. So the way you can think about this is, well, let's just say that our oxidation number for iron is X. We don't know what it is yet. And then you multiply whatever X is by the subscript of 2, and that's going to have to give you a +6, because +6 plus -6 is going to give you 0. And you need that because you have a neutral compound here. So you can ask, well, what does X have to be in order to give me +6 when it's multiplied by 2? And you can easily see that you're going to have a +3, because +3 times 2 is +6. So there's your oxidation number for iron. It's +3. So now let's go to the CO2 molecule in the product. Same kind of deal. Oxygen, almost always -2. You can do that one first. -2 times 2 is going to be -4. So what is oxidation number for carbon? Let's just call it X for now. Carbon has a subscript of 1. It's not written, but it's implied. So X times that subscript of 1 has to be +4. So you can easily see that X, because it's only multiplied by 1, is going to have to be +4. So there's your oxidation number for carbon. So what's going on here? Well, you can eliminate oxygen because oxygen's oxidation number in the reactants and the products is -2. So there's no change there. There's no oxidation or reduction going on with oxygen. But there is with iron and carbon. So you can see that iron goes from a +3 to 0. So that's an indication that you've had a gain of electrons. You've had an addition of negative charge, or a negative. So that means that you've gained electrons, and that means that iron is reduced. And then for carbon, you go from 0 to +4. So that's an indication that you've lost negative charge because you've become more positive. So what you can say about carbon is you've lost electrons, and that means that you're oxidized. And that's it.